Hello all. As you can see on your screens, there is a set of measurements that I entered into this G sheet, as it's called. So this is the free Excel offered by Google. Okay. So in case you're not aware, so yeah, this is the service that Google Sheets. This is what Google offers for free for anybody who has a Gmail account. Okay, so I highly recommend it. This is what I use whenever I have to use Excel, pretty much. Okay, so let's go to the Wikipedia page. So Google Sheets is a spreadsheet program included as part of the free web-based Google Docs editors suite offered by Google. Okay, so yeah, I'm making this video after a comment that a student included in under the Core Practical 9 video, but this video can also serve as a general purpose introduction to Excel for high school students or even anyone who is interested in using Excel. And additionally, this is not actually Microsoft's Excel. This is the Google's spreadsheet program, as we just discussed. Okay, so let me remind you of what Core Practical 9 is about. So it's so the Core Practical is about verifying the relationship that F. This is an online program I found that allows you to write things. So I'm sorry, but it's really hard to type with a trackpad. So F times delta T must be equal to delta P, the change in momentum. So the idea is that if you apply an external force, in this case, this force over here, with the hanger and the masses, so the lowercase mass m times g is the force exerted on this trolley, okay, this one. All right, so if this force is applied for some time delta t, and that time delta t is the time needed for the trolley to start from rest back here and cover this distance s, okay, so the force is applied for that amount of time, and the change in momentum can be calculated by multiplying m times the change in momentum, which is pretty much the final velocity because it starts from rest, okay, and the final velocity can be calculated using a light gauge that measures the time delta t needed for this cart that is attached. It's a very small cart attached on the trolley, okay, and the time needed for that small cart to pass through the light gate gives you the time delta t, which can be used to calculate the final velocity. Okay, so let's go back to the spreadsheet. Let me discuss a little bit about what I entered here. So you can enter values pretty simple. So I can actually show you. So trial, and then m hanging in kilograms. Oops, I don't know how I got there. So okay, this is trial. So you just click on a cell, and then if you double click, it allows you to enter whatever it is you want to enter. You can also enter values from here. So you see that I have the K cell, sorry, the K column selected. So let's say that I want M trolley. Okay, and you see that it's written, and then it's in kilograms, okay, etc. So you can enter names for your columns, and then you can enter numbers down here, okay. And if you do this, let me try. So if you go to the bottom right corner of a cell and you drag it like that, it continues with it enters the value that it's selected there by default. Okay, so it continues that. And anyway, I'm gonna do more demos later, but okay, for now the idea is that you do 3 trials, okay, 1 2 3, with the same hanging mass. Okay, the trolley's mass is the same, of course, for all trials. Okay, and then you measure the time needed for the trolley to go through to traverse the distance from back here all the way to the light gate. Okay, so to traverse this distance S. Okay, so we take 3 measurements, and then we have to take the average, and we also measure. Okay, so this is delta t pretty much. Okay, this delta t, and the second time there, you see that it's much smaller than the first one. That's the time needed for this playing card, this card attached to the trolley, to pass through the light gate. Okay, and again we have to take an average for that. Okay, so let me think about how I want to do that. Okay, we have the mass of the trolley. Okay, we need the distance. Okay, let me choose a cell. Let me come down here. So S is the distance from where the trolley starts until it traverses this level. Okay, so so in meters, S is 0.4. Okay, let's leave it there, and you will see how we can use it. Okay, what else will we need? We will need the length of the cart, which you call D here. Okay, so D, again in meters, it's 0.05. Okay, and the mass of the trolley, we can actually write it down here. We don't need to enter it as like a column that has repeated values. It's I don't know, it looks a little bit ugly. Okay, so 0.8 kilograms is the mass of the trolley. Okay, so actually let's call this column average, and you will see what I will do. So average. Okay, and let's say that this is equal to these 3 values. Okay, okay, sorry, this is not the way to do it. You can say that this is equal to the sum, okay, of these 3. Oops, sum of, okay, these 3 values over 3. Okay, so this is how you do it. You just enter this cell, you press the equal button, and then you select functions that Excel provides for you. Okay, so the average is 2. Oh, yeah, I'm sorry, I'm being stupid. So we want to find the average of these guys. Okay, I'm sorry. So sorry for the confusion. So I don't use this very frequently, so forgive me. Okay, so this is how you do it, over 3. Okay, so this is the average time for these first 3 trials with hanging mass 0.05. Okay, the mass of the trolley, we decided not to include it, so this is the average delta t, let's call it. Okay, like that. Okay, that we don't need, and we also need the average. Actually, let's move this, copy, and then Command X. Okay, okay, I copied and pasted to the next cell. You can use Control copy or Command copy if you're on a Mac, and then Command V or Control V, and you can copy paste things. Okay, all right, and here we will have the average gate time. Okay, and this gives you the velocity. Okay, don't worry, you can extend the columns to look larger like that. Okay, so this is equal, you press the equal button. Okay, and then we need the sum of these 3 values, right? And then you have to close the parentheses, and then over 3, and that's it. Okay, we have the value that we need, 0.07. all right, what else do we have to calculate? We need to calculate. Okay, first let's finish with the calculations. So now let's move to these 3 values. Okay, so let's make this equal to, I wonder if I drag it like this, will it do it? Okay, let me see. What did it do now? Okay, so if we go here, we will see that it calculated the sum of F7 to F9. Okay, so what is F7? So this is F7. No, this is not what we need. We actually need the sum of these three values. I'm hoping that I'm not confusing you. So let's delete all this. Okay, and let's do it properly. So this is equal to the sum of we need the time that the force was acting for the hanging mass of 0.07 now. So we will select these three, close the parenthesis over 3. Okay, and it's 1. This is surprisingly, yeah, it's a round number. Okay, so yeah, it makes sense. That's correct. Okay, and then this is equal to the sum. By the way, there is an AI, I guess, that suggests the value that you need. Okay, so they integrated AI into this. Let's see if it's correct. We need the sum of G7. No, that's not what we need. So you shouldn't always trust the AI. We actually need the sum of these three values, this, that, and that. Okay, over 3. Okay, and this is for a hanging mass of 0.07. Okay, I hope you guys are following and that all these things make sense. Okay, and you see that the time is faster. The time through the light gate, the time needed for this cart to go through the light gate is faster, which makes sense because the hanging mass is higher, right? Okay, now let's move here. Let's press equal, and then we need the sum for the next hanging mass, which is 0.09. So we need delta t for these three values. I mean, we need the average for those three values. Okay, so that's how you do it. Then you press equal and then sum, and this time it selected them correctly, right? Yes, actually the AI figured this out correctly this time. Okay, and then 0.09. Okay, the next value we have here in our table is 0.11, so let's start from there, 0.11, and then here we will have equal to the sum of this is delta t, okay, over 3. Okay, and then we need the sum. Okay, the AI is scary good sometimes. Okay, that's correct. This is what we need. Okay, now let's press equal, and then we need the sum of okay, the next mass is 0.13. We need these three values. Okay, over 3. All right, and you see how the time delta t becomes faster and the average time through the gate becomes faster. Okay, so now here we need equal to the sum of, okay, the AI is really good with the average gate time, but it's not good with the with delta t. I don't know why. So all 3 times are the same actually. Okay, and this is 0.13. Okay, so this is our 5 values that we have. Okay, actually let me extend this so we can write there that this is in seconds and this is also in seconds. Okay, all right. Okay, so remember that I'm gonna type it and then erase it. What we need to prove is that m times g times, let's call it okay, delta t. I have a Greek keyboard, that's why I was able to enter that delta. Okay, so this is equal to actually, so m times g times average delta pretty much. Okay, let's use the values that we have here in this table. Average delta, this must be equal to m, the trolley's mass, times delta v, which is nothing but v final pretty much. Okay, and therefore we see immediately that we also need to calculate the velocity. Okay, how do we do that? So let's call this v final, and it should be meters per second. Okay, okay, so we have to divide. Okay, this is equal to this d, right, which is the length of the cart, over this cell over there, which gives me the time that the cart needed to pass through the gate. Okay, oops, this is what we need. Okay, and to make it work, you go back here and you click into that window over there, and it should do it. Okay, and then you just drag, and it should calculate the velocity for all other values. No, it didn't do it. I don't know why. Okay, let me see. Anyway, okay, so we'll do it manually. So d, okay, this is equal to this over that. Okay, oops. So again, click back to that cell up there. Okay, then this is equal to this d over this value. Click back to the cell and go back here. Okay, it's kind of tedious, I'm sorry. There must be better and faster ways to do it, but again, I don't use Excel very frequently, so I'm not the best user of it. Okay, that's the other calculation, and then this is equal to this over that. Okay, all right, so you have the final velocity, and then remember that we want to plot the mass, the hanging mass times the average delta, right? So what we want to plot is pretty much, okay, can I erase this? Let me see. Okay, pencil, let's do eraser. Is there an eraser? Yes, okay, so let's erase this. So in the core practical, you need to, okay, let's go back here and choose the pencil. Okay, so we need to plot m, okay, first of all, m times g times delta t, okay, should be equal to capital M times the velocity. Okay, so we will plot m times delta t versus this velocity. Okay, this is the plot we want to make. So to make this plot, we need to also calculate m times delta t, and v is already calculated, so we are done with that. So we need another column here, which is the m hanging times average delta. I hope I didn't lose you here. Okay, so this is simply equal to this times that. Okay, then again, click back there. If there is a better way to do this, let me know in the comments. Okay, so okay, that's the value, and now I think if I drag it, now it will work. Okay, yes, it worked, and the reason is that when you drag, when you go to the lower right corner and you drag your cursor, what it does is that it repeats whatever the formula is that you entered there for this cell and this cell. You can read it off there. Okay, so that cell and then this cell. Okay, so you see that it tells you that I'm multiplying this and that. Okay, so pretty much we now have to plot this column versus this column. Okay, so we select these two. I think this is how you do it, and then you right click, and let's see if there is an option. Okay, no, there is no such option. So somehow, it's been a long time, guys, don't judge me. So yeah, we have to go here, insert, and okay, chart is not what we want. Cells, rows, okay, data. We need to somehow enter a scatter plot. Okay, this is what I'm looking to find. Let me see. So insert, let's try chart and see what happens. No, this is not what we want. Yeah, we can do a setup. So suggested, no, this is not what we want. So you do insert chart, and then we have to search for scatter. Okay, this is what we need. Okay, it tells you to choose the series. Okay, right now it's a mess, but I promise I will try to fix it. All right. So this versus okay, now I'm having trouble. Okay, let me see. Okay, so what did it do here? So yeah, it did it actually. But it entered. Okay, let me see. Okay, it entered the velocity down here. Okay, because you can see that for 0.09 of for velocity of no, this is not correct, sorry. So let me see. Customize setup, scatter chart. Okay, okay, let me see. So we need L5 to M10. No, that's not what we want. So for this one we need these values. Okay, and for this other one we need these values. Okay, let's press OK, and we have to reverse. Let me see. Okay, yes, okay, it did it. So we plotted M times the average delta versus the velocity. Okay, and let me see. Okay, so we have 1, 2, 3, 4 data points. What happened to the fifth one? Is it out of range? Okay, you see that for a velocity of 1.04, which is down here, we get 0.09. Okay, and somehow it skips. Okay, let's format it. Okay, all right, error bars, no, legend. Okay, horizontal axis, minimum value, let's do 0. And okay, the minimum value is okay, for the x-axis is, let's do 0.6. Okay, and for the maximum value, let's do 1.1. Okay, all right, and what else do we need? My problem right now is that I see 5 values here, but only 4 points plotted. I don't know why this happened. Which one is missing? Let's see. I'm doing this on the fly, so what if we do 0.5? No, 0.1, 0.6, and then let's do 1.3, maybe? No, I don't know what happened to the extra point. Okay, and then let's try the vertical axis. Oh wait, is it selecting? Okay, horizontal axis. Okay, let's go back to series. Okay, chart style, chart axis, series. Okay, it's been a long time, guys. Okay, let's do vertical axis. The minimum value of the vertical axis is 0.05, let's say 0.05, and the maximum value is 0.1, right? Okay, this looks better. All right, okay, let's close this. Okay, let's focus on this chart that we created. Okay, and another thing we can do is that I think we can enter, okay, chart area, chart axis, series legend axis, grid line, no. I'm trying to enter a line connecting the points. I don't remember how you do that. Okay, let's see. Insert, maybe you can do it from here. Drawing, no. Function, no. I think it's called trendline or something like that. This is what I'm looking to find. Extensions, help, okay, insert. Drop down smart, no. Image, no. Okay, let's go to Google. Create a scatter plot, then open the chart editor, go to the Customize tab, click on Series, and then check the trend line box. Okay, so chart area. Okay, if you double click it, it brings back this this menu on the right that allows you to do stuff. Okay, first of all, let me check the, okay, again, remember that I said that data point is missing. Let me see. If we do L11 and then we do M11, will it be better? No, it's still 4 data points. Okay, for some reason it skips one data point, and it skips the one at 0.05 and the velocity 0.67. So it should be there should be another data point down there. I don't know why it skips it. So okay, let me see. Okay, let's press OK. Okay, x-axis. I don't know what that does. Okay, let's do customize. Okay. Again, how do you enter this? The line. Okay, chart editor, customize, series, trend line box. Okay, customize, series, and then trend line. Okay, that's the line. Okay, perfection. Okay, the only thing that I somehow messing up is okay. Somehow it's missing that extra data point. I don't know why. Okay, I don't know why it's missing that, but anyway, I apologize. Something just went wrong, you know. But anyway, this is the general idea, okay? And if you press that trend line, I think it gives you the slope. No. Okay. Let's double click again. Customize. Grid line. No, this is not where. Series, and then trend line, and then label for the trend line. Use equation. Okay. So you see the equation of the trend line. So 0.115 is the slope of this graph. Okay. So 0.115 pretty much. Okay. So that should be equal. If we go back here, you see that should be equal to M, the mass of the trolley, over G. Okay, because that's the gradient of the slope. So let's check, is this equal to the mass of the trolley? We agreed that is 0.8, okay, and G is 9.881. Okay, let's see. We get a value of 0.08, which is kind of close to 0.115. So you see how the experiment kind of worked. Okay, and I know it's a mess. I'm still experimenting with how to deliver these lessons online and so on. I hope I haven't confused you terribly, and I hope that this was useful. Let me know in the comments. As you see, I don't use Excel very frequently, but when I do, I go to the free version that Google provides online, and you can also get access to that by having a Gmail account. Okay, and you enter your data and you play around with the functions provided, and if you run into trouble, you Google things like I did, and that's how you figure out things and you do experiments in physics, etc. So I hope this was useful. Again, this is to accompany the video on Core Practical 9, but also it can serve as a general purpose introduction to Excel sheets for high school students or even university students or anybody else who is interested in this kind of material. Let me know what you think in the comments, and hope to see you in the next video. Please comment. Please write in the comments whether this is useful or not and what I messed up and so on. And I hope I will come back with better videos in the future. See you in the next video. Bye.